This is session 3 on electrical power for the Airbus A320 family. Just wanted to make sure there's clarity on one of the questions for session 2. Just to reiterate, when we're talking about battery charging current being lower than 4 amps, then we're going to have the battery contactor open. Okay, just to be clear on that. So this is having to do with battery system functions. Battery charging current is lower than 4 amps, then the battery contactor is going to be open. It's going to open. All right, so on to session 3. This is our final session on electrical power for the Airbus. Emergency power. So we're on to emergency power, and there's different electrical emergency configurations that are possible, and that's going to affect what's going to happen with different other components. So what am I talking about here? Okay, well, there's different ones. One is going to be during rad extension, and then we're going to have a situation where both the engines fail. Okay, so both engines fail. That's going to be a domino effect with the supply of power from the main AC buses. Okay, so that's just giving you an example there. And I'm going to get into a little bit more on the different configurations, but what I want to do is address the main component that we're talking about in emergencies is the emergency generator, right? So emergency generator and the components there. So just to give you an idea of what we're talking about with the CSMG, which is short for CSMG, is your constant speed motor generator, and I'm also going to just go into the kind of the functions of the GCU, which I know I mentioned before, the talk about the generator control unit. But the constant speed motor generator has a hydraulic motor that powers it. Okay, and that hydraulic motor is powered by the blue hydraulic circuit. So you may see that on a test. It's not the green hydraulic system that it's getting supplied by, but by the blue hydraulic system. Okay, and powered by the blue hydraulic circuit or system in a RAT, okay, with RAT in emergency configuration. The hydraulic motor also, there's a speed regulation by the servo valve. There's also an integrated solenoid control valve. With the AC generator, it's a 3-phase, 115 volt, 400 hertz. That's your standard. And then output power is 5 kilovolt amps. The AC generator is oil cooled. Now for your generator control unit, the functions here is to regulate the generator voltage, also to control the servo valve excitation for regulating that speed, and then also just to protect the network. Okay, so one of the biggest dangers about an electrical system is having an over voltage, and or it could be an under voltage. So an over or an under voltage. You could also have over and under frequency. So there, we can talk about time delays, etc. But just know, this is not an electricity class, but just know that those protections are there with those time delay types of electrical components. Okay, so what do we mean by the generation of AC emergency power? Okay, so when we have this, we're talking about in the case of losing our 2 main generators. Okay, we're talking about AC, and that's your 2 IDGs, right? So you have 2 IDGs, and then next would be the auxiliary generator. So if that's not available, and we don't have the IDGs either, then we have an AC emergency generation system. What comprises the emergency generation system? What kind of components do we have that define it? Well, that would be your CSMG, the control unit, and the contactor for the emergency generator line cuts. What is emergency generator line contactor? And then you have a contactor for the AC essential bus. And then you also have a timer. Okay, the timer is just avoids the closure of the contactor, a certain contactor, in case there's an electric transfer Okay, the hydraulic motor drives the emergency generator, and then you also have that servo valve speed regulator that controls the speed. With that, when there's those conditions met for emergency, remember I mentioned about the blue system. Blue hydraulic system is the one that supplies, or is supplied by the ram air turbine. So blue system, remember, from hydraulics, and I was talking about that. That's what that is. So we have the blue hydraulic system that's supplied by an electric pump in a normal configuration. All right. Okay, so electrical emergency generation system. We're going to be talking about RAT. We have to. Okay, that's going to be automatically controlled by the loss of the two AC buses. But in addition to that, it's also when you have the aircraft speed at greater than 100 knots. There's going to be different conditions. So I'm going to go over some different little details here. Again, depends on what configuration we have, you know, what kind of conditions we have. So in this case, we're talking about, you know, an automatic control of the RAT and the CSMG, okay, because of the loss of AC buses, and the airspeed is greater than 100 knots, or you know, by manually, okay, when you push the emergency electrical power manual on guarded switch. That switch, you know, then you're controlling the RAT and the CSMG. So if, let's say, both buses fail at the same time versus one first and maybe later the other one goes, but let's say this at the same time, then there's going to be an automatic extension of the RAT. Okay, so all these three conditions are going to happen. You're going to have that, and then you're going to have the emergency generator automatically be coupled to the essential bus bars. Then you're going to have a red fault legend that's going to come on RAT and emergen enunciator until the generator's available. So those are the three conditions going to happen there. You can do a test of the emergency generator because there is an emergen test push button switch. This is for ground testing, so you can make sure that the emergency generator is working. That information is going to, of course, display on the ECAM, and it's going to be coupled to its network. So we got contactors, you know, that are going on there. Also, if everything's normal, you're going to have green lines between normal bus bars and essential bus bars that are not going to be there. So those don't even exist there if everything's, if you know, things are good. So here there's a white emergen essential transformer rectifier, and there's also green indications of the corresponding parameters that appear. Okay, so there's that. You can test the generator generator control unit, okay, the emergency GCU, from the ground, and that's going to be, or on the ground, and that's from the CFDS. Okay, so just a little bit on the RAT extension. Remember what I said, 3 conditions in which you can have then the RAT extended. There's also 3 different logics that control the extension of that RAT. So what are they? Okay, one way is there's 2 manual and 1 automatic electrical logic. So on the manual logic, you have manual electrical logic and manual hydraulic logic, and then your 1 automatic one, which is electrical. So on your manual side, there's 2 push button switches. One is your elect power man on, and then you have your hide RAT man on. Okay, those are identifiable on the control panel. So both of those is when you can have or extend the RAT. There's an automatic extension. Okay, so that's going to be there, and again, remember what I said, that's loss of a certain voltage for the AC buses. Okay, remember what I said, if you see XP, XP is for alternating current. So bus bars here in this particular case are identified as 1XP and 2XP. Okay, remember the other condition is that the aircraft speed is greater than 100 knots. Because later I'm going to be talking about you know, a range of speed, of aircraft speed, and what happens, you know, under those conditions. But here it's when the speed is greater than 100 knots. All right. Okay, so and then just on the GCU test, okay, it's emergency test procedure using the MCDU. So using the MCDU, here with the emergency GCU, it's a Type 3 system, so it doesn't have an input or an output bus because it's directly connected to the CFDIU. That's what defines it to be a Type 3. So the way you're going to do this is to access the operational test of this, you know, the GCU from the CFDS. You have to adjust the brightness of the MCDU screen and then push that MCDU menu mode key just so you can get it to be seen, so you can see it. And then push the line key that's adjacent to the CFDS indication. That way you have the CFDS menu page come on and you can see that. And then the next thing you're going to push is the line adjacent to the system report test, if you've seen that. So system report test indication, then that's going to come on. And then there's another one for that's adjacent to the elect indication. And then you have also the GCU EMR indication. Then you're going to have the GCU EMR page come into view. So you'll have that. And then you'll have one for test indication. Okay, so if the test, you know, pass the test OK message, it'll show up on the display, and the red indicator light on the CSM GCU will extinguish. It'll go away. So if it passes the test, it says test OK, then a red indicator light is going to disappear after 10 seconds. If it fails, then you're going to have a GCU EMR page that will show the related fault and let you know what that is, what component. Okay, just kind of a note on the GCU EMR test. When you're doing it through the CFDS, typically it requires 2 AMTs. Okay, because one's going to be doing the MCDU functions and the other one's going to identify or make sure, you know, to watch the illumination and extinguishing of the red indicator light on the CSM GCU. Okay. So, and there's a sample picture. You can see how the display is. It'll say GCU EMR at the top, and if it passed the test, it'll say test passed. So that's good. Or if there's something wrong, then you know it's gonna let you know what it is. Alright, so you've got also the issue with the landing gear being extended or compressed during an emergency configuration. So, you know, there's some different things here that I want to mention. So you could have something that's greater than 50 knots and greater than 100 knots. Okay, and then also just again whether or not when you have the landing gear extended or compressed. So let's just say that in the case of having the landing gear down, okay, when you have the landing gear down, there's not enough power to operate that CSMG. Okay, so because of that, then the emergency generation network is going to transfer to the batteries and the static inverter. Okay, so what happens when that happens? What happens? Okay, that's going to imply now the shedding of the AC shed essential buses, you know, the AC and the DC. That's what's going to happen there. Now, if you have a rat stall, or if you have the aircraft on the ground with a speed below 100 knots, but let's just say rat stalls, okay, then you're not going to have enough power for the CSMG. So same situation is going to happen. So whether you have the landing gears down or you have the rat that's stalled, then that emergency generation system is just going to transfer over to the batteries and the static inverter. Now, let's say that you have the landing gear extended, then at go around, it's possible to restore the emergency generator. You can get that back online by opening the circuit breaker that's associated with the landing gear CIU 1 and also pressing the man on push button switch. So This is on the 21 VU. Remember, 21 VU is the emergency panel. So it's possible to restore it. Just giving you some knowledge here about how to do that. Or if it's retracted, because that was the landing gear in extended configuration. You know, if you have, you know, in landing gear extended configuration, you have the crew wants to say retract the landing gear, then they're going to have to do man on. Okay, just, you know, they need to do man on, and when they do that, it's going to restore the emergency generator back on. Okay, so just some more on the static inverter, because I've mentioned that about the batteries and the static inverter that, you know, now carries on the burden, if you will. So in those conditions, so the static inverter, okay, that's going to start automatically if you have those two AC buses, you know, lost, and also that CSMG is just not available, and the speed is more than 50 knots. So here, if speed is more than 50 knots, you're going to have an automatic starting of that static inverter. Now, if there's something wrong with the static inverter, then it's going to send a permanent ground signal to the battery charge limiter 1. It's going to store that in memory as a class 1 failure. So just remember this, static inverter, if there's a fault there, if there's something wrong, that's a class 1 failure. That information is going to be sent over to the BCL1, battery charger limiter. Okay, so the whole idea here, if it's faulty, there's a concern here for of either output over voltage, or you may have an input under voltage or input over voltage. So input over and under, or an output over voltage, or you just have an overheat, you know, just something that's been overheated, and that's going to send that message to the ECAM. It'll be showing up as static in fault, an INV. The fault indication will be available for, you know, during the BCL byte reading. That's going to come from the CFDS. Okay, so remember, okay, so that's one thing. And then, you know, so that when the airspeed is greater than 100 knots, okay, the CSMG supplies the AC essential bus and DC essential bus through the essential transformer rectifier. So that's a function of the essential transformer rectifier, the TR, is to, you know, be able to kind of have that communication between the CSMG and being able to supply that power over to the AC essential buses. Okay, but what about the speed between 50 and 100? Okay, so we get speed between 50 and 100 knots, then there's just, the emergency generator is not going to be connected to the aircraft network. Okay, it has to be greater than 100 knots. So, you know, what's going to happen in that case is that the AC essential bus is going to be supplied by the static inverter. Okay, remember I was saying before, you know, here it needs to be at greater than 100 knots. You're going to have that CSMG supplying that power. But if it's under that, then the CSMG is not going to be supplying that power. And instead of that, you're going to have a static inverter that's going to be supplying that. And that static inverter power is going to be coming from battery 1. Okay, so it's just all this priority going downward, if you will, in one respect, down to the DC power being able to, you know, have that energy be transferred over to static inverter in order to have an output of alternating current. Okay, that's necessary. Now, on the flip side, you have the DC essential, because I just mentioned the AC essential bus, but, you know, on the flip side, you have a DC essential bus, okay, that gets directly supplied by battery 2. Okay, so you have a static inverter that is supplying power to an AC static inverter bus. Okay, so there's that. And that bus in particular is used for the APU fuel pump supply. Okay, so you have that. Now, what about the airspeed less than 50? Okay, so we had, at the beginning we had greater than 100, then we went to between 50 and 100. Now, what about less than the 50? Okay, so in this particular case, you know, now we don't have a connection between the static inverter and the AC essential bus. Okay, so that just it doesn't happen. So now, but that's just going to kick off. But the DC essential bus and the AC static inverter bus will still, have supply there. Okay, now testing the static inverter, you need to press the emergency generator test button, and you got to hold it. Okay, so that's the emergen test pressed in and held, because what you're doing when you're doing that is you're simulating an airspeed of greater than 50 knots. Okay, so that's on the ground. The static inverter can be checked by doing that. Okay, and just to describe a little bit about the static inverter, besides what I mentioned, it's a 1,000 volt amp nominal power static inverter that transforms that direct current voltage, okay, into a single phase AC. Typically, your 115 volt AC is going to be a 3-phase. For you avionics technicians out there, you know what I'm talking about. For those of you who are not, you may be in the dark of what I'm saying right now, but this is all the concepts of electricity, but and phases and frequencies, etc. But here, this is just basically enough for being able to supply that AC power. Okay, but that's what happens when you're taking DC power and converting it into a single phase 115 volt AC. Okay, so when do you use the static inverter? When does that get used? Okay, it's going to be during your RAT deployment. Also, if on the ground there's only batteries available, then you're going to have a static inverter, because your batteries are DC, right? So if you needed to have AC power, you need a static inverter. Also at APU start, okay, or engine start on the batteries. Okay, the other time too is an emergency configuration after landing. Okay, think about, so what I was saying before, there's different kinds of emergency configurations. I know when we mentioned before, or talking about in the overview as far as emergency configuration, we're talking about, okay, what's our main source of AC power? Our IDGs. What's next if one of them fails? We have an auxiliary generator that's APU driven. Okay, next down is going to be an emergency generator. Okay, but there's different, like I just mentioned before, about aircraft speed being a certain number of knots, etc. And then what gets automatically triggered. Okay, so here on certain variants, when you have an emergency configuration after landing, so the static inverter can be used here when the CSMG is switched off. Okay, then the static inverter is available there for AC. Okay, what are the components that we can identify with the static inverter system? Well, there's going to be, of course, a static inverter. Where is that located? Okay, that one is in the avionics compartment, right? That's going to be on the right-hand side. So you get right-hand forward part, and you can access it through a door there. It is located on a shelf in there between frames 14 and 15. Again, check with your AMM specifically for the aircraft that you're working on. Okay, and then you also have a contactor. You also have a bus fuse. Okay, so those are also there in the forward avionics area. All right, so and then we have some AC essential generation switching. They're basically controlling the supply of AC distribution, right, throughout, so that it can go to the user systems, but it's controlling that supply. They basically enable the normal supply when the plane is in a normal flight condition. It also can enable the transfer of the supply in case that one of the AC buses, actually the first one, so AC bus 1 is not working. Then it can do an automatic transfer to the other bus after so many seconds. Alright, so the switching contactor, that one is obviously in the avionics. That compartment, that is on 106 VU panel that you can access through a door nearby. Okay, So kind of just be aware of the different buses. Well, what happens when you have the loss of one. Obviously, we're going to be involving the shuttable essential bus bars, right? Those are normally supplied in series from the AC bus 1, okay, through the contactors. Contactors like the go between, right, to make that happen, to make that connection. Okay, so that gives you an idea. So that gives you an idea with the emergency part and the static inverter that comes into play and what it's used for, in what instances is that used. And also just the kind of knowing that there's different configurations based on variants of the aircraft as well, besides models. So kind of keep that in mind. There may be just slightly different procedural electrical procedures based on the aircraft variant. Okay. All right, so we're going to go ahead and do some knowledge checks. Okay. What is one way that the RAT and CSMG are controlled? Okay, is it through when AC bus 1 and 2 are lost, or aircraft speed is greater than 100 knots, or when AC bus and 2 are lost and aircraft speed is greater than 100 knots? Okay, the answer is the last answer. Okay, remember, a lot of these things are, when we talk about logic and sequences and things having to do with this, with systems, there's a lot of, it could be either or and or. Okay, pay attention to that because it is important to know, is it only in this case, or, either this or that, or is it that both conditions have to be present in order for something else to happen? So in this particular case, both of those have to be there. Name some components of the emergency generation system. Okay, so option A, CSMG and GCU, or the RAT and GCU. Okay, the answer is the first one, CSMG and GCU, right? The hydraulic motor, which is incorporated in the CSMG, is powered by which hydraulic system? Okay, option A, is it green or blue? Okay, it's the blue one, right? When there exists failure of both AC buses, the RAT is automatically deployed. Is that true or false? Okay, that's true. When there exist failures of both AC buses, the red fault legend comes on RAT and emergen annunciator. Okay, until the generator comes on. Is that true or false? Yeah, that's actually true. Okay, in what instance does the emergency generation system transfer to the batteries and the static inverter? Okay, option A, is it if the RAT stalls? Or B, if the aircraft's speed is below 50 knots? Okay, the answer is A. Remember I mentioned about RAT stalling. Okay, what three conditions are necessary in order for the static inverter to initiate automatically? Okay, option A, either AC bus or bus 2 is lost, CSMG is not available and the speed is more than 50 knots, or is it both AC buses are lost, CSMG is not available, and speed is more than 50 knots? Okay, the answer is the second one. Both AC buses are lost. That's the key thing. Okay, a static inverter defect is a class 3 failure. Is that true or false? Okay, that's false. Remember I said it's a class 1. Under what condition is the emergency generator no longer connected to the aircraft network? Okay, is it under the condition of airspeed being between 50 and 100 knots, or under the condition of the airspeed being between 100 and 200 knots? Okay, the answer is the first one, right? Between 50 and 100 knots. All right, when the airspeed is less than 50 knots, the DC essential bus is no longer connected to the static inverter. Is that true or false? Okay, let me read it again. When the airspeed is less than 50 knots, the DC essential bus is no longer connected to the static inverter. True or false? Okay, that's false. It is still connected. Okay, when the airspeed is less than 50 knots, the AC essential bus remains connected to the static inverter. Is that true or false? That's also false, because when it drops below 50, it gets disconnected from the static inverter. Okay, how do you simulate an aircraft speed of greater than 50 knots? Option A, press and hold the bus tie push button switch, or option B, press and hold the emergen push button switch. Okay, it's the latter answer. Okay, the second answer. Okay, so that concludes session 3. Hope that gives you definitely more, to add to your knowledge. Certainly, if you have any questions, definitely email us. Okay, we look forward to you participating in the other modules.